Bon Jovi, right? You all knew it was Bon Jovi. I hope you did. Well, I hope you enjoyed that because I did. Okay, seriously, I am going to turn off my music this time, okay? Because we have some algebra to do. So I am going to go over an example for absolute value equations on the board. I'm going to go over one example that would have been something like that you did on the homework assignment today. And then we're going to go over a couple other things that are included in section 1.4 that you haven't had yet. And then you'll probably want to look in Google Classroom later on or tomorrow morning for an assignment sometime in the next day or two on these next sections. Okay, so let me write down the first problem that we're going to try. And I've got my little notes here. So the first one that we're going to do, and hopefully you can see this okay. I'm going to try to write it dark enough so you guys can see. Got -2, and then the absolute value of 5x minus 1 minus 3 equals -11. So your job here to begin with is you need to isolate the absolute value expression first before you start solving the two different ways. So this one, as you can see, it has a -2 on the outside of it being multiplied to that whole thing. And then it's subtracting 3 here. So we want to, just like in regular equations, we want to get rid of things or eliminate things on one side through addition or subtraction first, just because usually it's easier. So what I'm going to do is I'm going to add 3 to both sides. Okay. From there, then I'm going to still have your -2, the absolute value of 5x minus 1, equals what -11 plus 3 is, which is -8. Okay? So notice how, again, I rewrite everything every step of the way. All right? Now, at this point, I still have a -2 on the outside. This -2 is being multiplied to this whole thing. It's kind of like parentheses. Okay? So I want to get rid of this -2. You don't necessarily want to do the duck here or distributive. You want to get rid of this -2 on the outside of the absolute value expression. So I'm going to divide both sides by -2. And now finally, I have the absolute value expression by itself. -8 divided by -2 is 4. So it's at this point that you finally get to start solving for the variable. So right now, this absolute value, whatever's inside here, can either equal a 4 or it can equal a -4 because the absolute value of -4 is also 4. So this is the point where you would draw your two arrows and try solving the two different ways, okay? So I'm going to right now, since I'm kind of running out of room here, I'm going to rewrite this part up here, okay? So we have more room to solve the two ways. So as you can see, doing absolute value equations uses up a lot of paper, okay? Okay, so we've got the absolute value of 5x minus 1 equals 4. So at this point, you want to draw your two arrows, and you have to solve two ways. One big reason why I have you guys draw the arrows is because some students will forget to do it both ways. They'll only solve it one way. So if you get in the habit of just drawing two arrows, you'll remember, oh, there's two different ways I have to do this. So the inside of the absolute value, notice I bring it out. Notice I don't have any absolute value symbols here. I want to know what the inside can equal. And it can either equal 4 or it can equal -4. And then you solve. You solve just like normal. So I want to add 1, 5x equals 5, divide by 5, divide by 5, and x is going to equal 1. Okay? Now you're going to do the same thing over here. You're going to end up adding 1 to both sides, but you get a slightly different answer. I'm going to add 1 to both sides. I get 5x equals -3. Divide by 5, divide by 5, and x equals -3/5. Or you can tip it over and get a decimal. But this is fine, just the way it is. Now, if you want to double check your work, you would plug them in. You know, you'd plug in your 1, you'd get 5 times 1 is 5, 5 minus 1 is 4, absolute value of 4 is 4. or you plug in the negative 3/5. And remember, over to the side, if you need to do it, okay, you can go over to the side. I'll go here. You can go over to the side and do your 5 times your negative 3/5. And if you notice when you do that, your 5s are going to cancel out. They're going to cross simplify. So you actually end up with just negative 3. So that whole thing would equal negative 3 minus 1 is negative 4. Absolute value of negative 4 is 4. So both work, both these. So you have 2 answers. And in your homework, some of the questions ask for you to graph it. That means graph it on a number line. And that only means that you're going to plot those points. So you would plot where you think a 1 is on a number line. And of course, you're going to put 0 and then a 1 and then put a dot on the 1. And then you need to figure out where negative 3/5 is. And it'll be interesting because usually on the fractions, some kids won't get those correct. So be careful. Negative 3/5 is not 3.5, negative 3.5. So be careful on that one, okay? So that's just a little review. You can go back over this or use this again, or I had the other video to help explain things, okay? And if you want to reach out and look up other videos online, that's okay too, okay? There's lots out there, okay? Okay, the next thing I want to show you is there was a trick question, or there is a trick question if you haven't done it already. I'm going to give you an example. Here's an example of one like it. This says, if you can see it okay, it says absolute value of 3 plus x equals negative 3. Now, there's probably going to be some of you that are going to work this out, and you're going to have some problems with it. So what I want you to do is I want you to look at this right away and think about, why can this not happen? There's no way that this equation is right. Do you know why? Hopefully some of you will see the absolute value of anything can't be negative. So no matter what you put in here, no matter what you put inside here, you're going to take the absolute value of whatever you get. And absolute value is always positive. So there's no way you'd ever get a negative 3. Okay. Now this doesn't mean that x is negative 3. It means the whole thing, and you take the absolute value of it, is negative 3. And that can happen. So be careful of ones like that. They're trying to trick you. Okay. And there is one on your homework. So hopefully you'll find it. Okay. Now, the next one I want to go over is you're going to get equations with variables, or I'm sorry, with absolute value equations on both sides, or absolute value expressions on both sides. So I'm going to show you an example of that. Okay. So I'm going to write this one out here. So it's going to look something like this. I want to make sure you see all of it. I'm going to write it a little bit higher. Okay. So we'll have some room. 2 times the absolute value of 4w minus 1 equals 3 times the absolute value of 4w plus 2. Now notice I try to make my absolute value lines longer than a lot of my numbers, only because you don't want to get confused and think that your absolute value symbol is a 1. So be careful. I try to make them long, or you can use different colors if you want to, but you just want to be careful about that. Now the absolute value symbols look a little bit like parentheses in this equation, but they're not parentheses, but you can sort of treat them like that in some cases. So for example, in this scenario, when you have absolute value on both sides, you don't have to isolate one of them. You're going to work with it as is, okay? So for example, on this one, you're going to actually do kind of like the distributive property with this. But remember, in the other equations that we solved, you solve it for the original answer, and then you solve it for the opposite answer, meaning the negative of it. Remember, in the last one we just did, the answer could have been 4 or negative 4 inside the absolute value. Same thing here. So here's what you're going to have to do, okay? The absolute value, you pick whichever side you want. I always pick the right side to change. I keep the left side the same. I never mess with it. I just keep that one. And this is the one that I'm going to do the opposite of eventually. So we're going to actually go straight away into your 2 ways when you have absolute value on both sides. So this one is going to be 2 times 4w minus 1 and you switch it to the parentheses. Now over here, I'm going to go 3 times, oh, I'm sorry, I didn't finish that one over here. Let me draw that a little better. Hold on, okay. Let me do this a little better over here because they take up a lot of room. 2 times 4w minus 1 is going to equal 3 times 4w plus 2. Notice I didn't change anything except for I just switched out the absolute value for parentheses because we are going to do the distributive. But this side is normal. It's the original, okay? Now the other way, I'm going to have to do the opposite of it, meaning the negative of it. So I'm going to pick one of the sides to stay the same, which I always pick the left. And then the other side, I have to take the negative of what's inside the absolute value, okay? So whatever's inside here, I got to take the negative of it. So I don't take the negative of the 3. I'm taking the negative of what's inside the absolute value. So this turns into negative 4w minus 2. Okay? Just like earlier when we did the first example, where you ended up with absolute value of 5x minus 1 equals 4. We kept the 5x minus 1 equals 4, the original, and then the second one we did 5x minus 1 equals negative 4. We did the negative of it. So that's how we did it here. It's the negative of the absolute value part. Be careful. It's not this one. It's the absolute value of what's inside. And then you solve, okay? Then you solve. Oh, I guess I put absolute value here. Okay, now one at a time. Let's just solve it. We get 8w minus 2 equals 12w plus 6. And you solve. You got variables on different sides. Got to get them on the same side. So I'm going to subtract 8w to both sides. I get negative 2 equals 4w plus 6. Now I'm going to subtract the 6. I get negative 8 equals 4w. Divide by 4, divide by 4, and I hope you can see this, negative 2 equals w. So there's my first answer, okay? Now notice on this part right here, I didn't get rid of the negative 2 because then I would have nothing over here. I have 0, and everything would be over here. I'd have the variable and some extra numbers, so I need to try to figure out which would be best, okay? Which would be the least amount of steps. So now let's try this one, okay? So again, I'm going to get 8w minus 2 equals negative 12w minus 6. Solve. Now this time, I like to keep my answers positive, so I'm going to add 12w. That way, I know I'll get a positive 20w on this side. Minus 2 equals negative 6. Then I'm going to add 2, and I get 20w equals negative 4. I'm going to divide by 20, and I get w equals negative 4/20, or if you simplify, you're going to get negative 1/5. Okay? So on this one, or you can dip it over and get a decimal, but you don't have to. Okay? Now on this one, you get 2 different answers. Okay? Just like the other ones. You just have more work to do to figure it out. But it just takes time. The steps are not more difficult. You just have to take more time to solve them because you have to do 2 different ways. Okay? What do you think? Good? I hope so. Okay. Now, I'm going to go ahead and erase all this. If you want to take a look at it. Hopefully I didn't make a mistake. Okay. Now the next thing I need to talk to you about is I want you to know what an extraneous solution is. An extraneous solution is a solution that you can reject right away. You don't, once you get the answer, you know that there's no way it will work in the equation. So I'm going to write one down here so you can see what one of those would look like, okay? So let's say you would get, let's try this one over here. Let me get this one. Okay, there's an example in your book. It looks something like this, okay? 2x plus 12 equals 4x, okay? So my absolute value expression is already by itself, so I don't have to do anything. I can right away do my two ways. Okay, so 2x plus 12 can equal 4x, or 2x plus 12 can equal negative 4x. And you solve. Subtract, oops, my bad. Subtract 2x from both sides. You get 12 equals 2x. Divide by 2, and you're going to get 6 equals x. So there's one of your answers, okay? Now the next one, hopefully you can see this. I'm kind of far away from the camera. But if I subtract 2x on this side, I'm actually going to get 12 equals negative 6x. When I divide by negative 6, I actually end up with negative 2 equals x, okay? Now, the negative 2 is considered an extraneous solution because when you look up into the original problem, wherever there's an x, you have to put what you think x is. So on here, x is 6. Well, 6 times 2 is 12. 12 plus 12 is 20, 24. 4 times 6 is 24. So you get a balanced equation. Both sides will equal 24 when you plug in 6 for x. But with a negative 2, look what happens. You're going to get negative 2 times 2, which is negative 4, plus 12, which is 8. But on this side, what's going to happen? If x is negative 2, you get negative 8. Well, the absolute value of anything can't be negative. So this can't work. This one can work. So you actually get one answer, not two. So this one is called extraneous. There's no way, I mean, it actually, we solved it correctly, but it's called an extraneous solution because this one immediately you can eliminate as an answer because it won't work in the original equation. Okay? So hopefully that makes a little sense. All right. Now, I'm going to do one more example before I let you go. Okay, so let's see here. There was one more I wanted to try with you, I think. I am wrong. I think we're good to go. Okay, so here's what I want you to do. If you have any questions about any of these, let me know, or refer back to the video, or if you want to look up anything, or if you need me to find another video or reference for you, I can. There's examples in the book. You can follow those as well. But I am going to be giving you an assignment on Google Classroom. So check back with that tomorrow morning and see what's there. I do want to see people's work before I try to assign this next part in section 1.4 so I can make sure that everybody's on the right track. So those of you that are on target and staying up with the assignments, you might have a day where you don't have anything. So check it out tomorrow morning and I will see you soon.